Okay, Dan Heckman here again for the final time in this chapter of immunology. And now we're going to talk about immunosuppressants. Can you think of a time where you might need immunosuppressants or drugs that quiet the immune system? How about an organ donation? The first immunosuppressant that is commonly used is cyclosporin. And do you know off the top of your heads what this does and how it inhibits the immune system? Specifically, what cells it inhibits? Well, it's mostly T cells, and you'll see why. So let's show the normal process first that takes place in activating T cells, and then we will show what cyclosporin does. So remember interleukin-2, this was the pro-T cell stimulating cytokine. And this is what you may not remember, but the downstream effects of interleukin-2 binding to this interleukin-2 receptor on T cells leads to activation of cyclophilin that then causes a cascade of events and stimulation to occur. Cyclophilin stimulates calcineurin that then in turn stimulates NFAT, which is a nuclear transcriber protein and facilitates the production of other cytokines and other proteins that are pro-inflammatory, that further the response. Recall that T cells are, at least the CD4 T cells, are the cheerleaders of the immune system. So production of proteins that spur on the fight against the pathogens. Now, what does cyclosporin do to disrupt this? It binds to cyclophilin. So they both start with a cyclo. It's kind of one easy way to remember that. But the binding of this prevents the downstream effects from occurring and prevents the production of cytokines and pro-inflammatory signals to other cells. All right, one thing you should know about cyclosporin is that it is very toxic to the kidneys. And they may ask about that on boards, about the number one side effect. So it's important to monitor the renal function when patients are on this medication. Next up is tacrolimus, which really acts very similarly to cyclosporin, except that instead of inhibiting cyclophilin by binding directly to it, tacrolimus activates the FK binding proteins to inhibit cyclophilin and in turn disrupt the downstream effects of transcribing pro-inflammatory cytokines from T cells. Sirolimus also prevents the activation of downstream effects of interleukin-2 in T cells. However, it works a little bit differently than tacrolimus and cyclosporin, in that it disrupts the mTOR, the MAP kinase cascade. Now, do you know what the significance of this would be? Basically, less cell proliferation and growth and replication. When talking about side effects, it's important to know that although tacrolimus and cyclosporin were renal toxic, sirolimus is not. So when using sirolimus, the kidneys survive. While we're on the topic of interleukin-2 disruptors, basiliximab is a monoclonal antibody that binds to and thus prevents the binding of interleukin-2 to the T cell interleukin-2 receptor. Another monoclonal antibody that you should know that works almost exactly similar to basiliximab is almost as fun to say, daclizumab. All right, and it basically does the same thing. Prevents interleukin-2 from binding because this antibody, one of these two antibodies, is taking up that space. Azathioprine exerts its effects through toxicity to proliferating lymphocytes. And specifically, this is an anti-metabolite precursor of 6-mercaptopurine. And so it interferes directly with the synthesis of nucleic acids from being linked onto growing strands of DNA. So without DNA replication, we have inability of immune cells to proliferate, and thus they are inhibited. Mycophenolate mofetil also disrupts DNA replication, but it works a little bit higher up the ladder in that it inhibits the enzyme IMP dehydrogenase. Maybe you remember from biochem. I think it's in that section in your books. But inhibition of this enzyme leads to less purines and less purine synthesis, and thus ultimately less DNA replication. Glucocorticoids, incredibly important to know for boards. You'll see this a lot throughout your texts if you haven't already. Also called corticosteroids or just steroids for short. But let's just talk about how they work here. So they basically turn off the immunologic on switch. And what is that exactly? It's this, NF-κB. So with turning off the on switch, proliferation and synthesis of stimulatory cytokines is disrupted. And that's all we're going to say right now, but just get ready to really be immersed in corticosteroids for the rest of this book and your lives. Flash quiz time. An important question to answer for you. Which immunosuppressants can lead to renal dysfunction? Cyclosporin and tacrolimus. Which one is notorious for allowing the kidneys to survive? That's right, sirolimus. The purpose of this slide is just to sum up what we've talked about with the previously mentioned immunosuppressants thus far. So, let me ask you a question. Which immunosuppressant inhibits interleukin-2 receptor directly and competes with interleukin-2 in binding the receptor? That would be basiliximab and daclizumab. Very good. Okay, which one disrupts the mTOR and MAP kinase cascade? Sirolimus. Very, very good. The kidneys survive, remember. All right. How about the calcineurin cascade? Which one or ones disrupted this? Cyclosporin, tacrolimus, which tacrolimus worked through the FK binding proteins. Both of these disrupt cyclophilin by binding it and preventing the stimulation and activation of this cascade here. All right, and then again, steroids inhibited NF-kappa B. And what is this again? It's the on switch for immune cells. Let's now talk about some of the more important artificial cytokines that we've made in the lab and what cells they stimulate, as well as when they're used. First one is aldesleukin. What does it do? It pretty much acts just like interleukin-2. Therefore, what cell does it stimulate? T cells. We use it to stimulate CD8 cells to apoptose malignant melanoma cells. Next one is erythropoietin. You probably all know this one. And if you don't, the first part of its name sounds like erythrocyte because it stimulates the production of erythrocytes in the bone marrow. Filgastrum and sargramostim, kind of fun words there. A mnemonic that helped me is gram sounds like granulocyte, and that's because these stimulate granulocyte production in the bone marrow. Recall that interferons essentially act as mini highlighters of cells that need to be apoptosed. So cells infected with a virus or cells that have undergone malignant transformation. How do they do this again? So they basically increase the MHC1 receptors on the surface of these bad cells and call more attention to them so that the immune cells, which are like CD8 cells and natural killer cells, can easily find them and easily apoptose them. Disease states in which we would use alpha interferon, do you know? Hepatitis C and hepatitis B. I'm just going to list them. No easy way to remember these facts. Beta interferon is used in multiple sclerosis. And finally, gamma interferon. It's not listed here. A fun tie-in is that it's used in chronic granulomatous disease. Oprelvicin and thrombopoietin are classical agents that act like interleukin 11 to increase the production of platelets from the bone marrow. Think of thrombus, then you'll remember platelets. Rhamaplastum and L-trombopag are newer agents that act in a similar fashion. Sorry, they sound like Lord of the Ring characters there, but they all increase the production of platelets. Keep an eye out for therapeutic antibodies that will definitely be mentioned in almost every pharm section of every chapter of your first aid text. You'll see them combating certain types of cancers, various autoimmune diseases, and other conditions. Well, that's about it for immunology. Thanks so much for listening, and we'll see you next time in the pathology section.